My name is Zachary Moore, and I will be talking about nuclear powering the U.S. So for this, my objective here will be to calculate how much the United States could reduce their CO2 production in 1 year by switching all fossil fuel-fired electric power plants to nuclear-powered plants, and estimating how much it might cost. In order to do this, I will gather the past year's electric demand of the U.S. from the EIA and how much was produced by nuclear power. I will then calculate approximately how much CO2 is produced from the nation's coal and gas-fired power plants in 1 year. This will then tell me how much the U.S. could reduce from switching to all nuclear, as this is a carbon-free source of energy. So first things first, I had to collect some data. The EIA website has years of data on energy production and carbon emissions in the US. From this website, I found the shown tables on the right. Here we see that over 62% of the United States electricity generation comes from fossil fuels, primarily natural gas, with 1,582 billion kilowatt hours. Coal, which produces 966 billion kilowatt hours, and some from petroleum, which is 19 billion kilowatt hours. I also found a tabulation of CO2 emissions by source, which actually reduced my calculation workload by quite a lot. From the bottom table, we see that natural gas produces the least CO2 per kilowatt hour, averaging about 0.92 pounds per kilowatt hour. Coal is the most at 2.21 pounds per kilowatt hour, and petroleum produces 2.11 kilowatt hours. In analyzing this data, I used this information and some help from Excel. I was able to easily calculate the amount of CO2 produced by natural gas, coal, and petroleum in 2019. We see that natural gas produces 1,585.86 million metric tons. Coal produces 403.12 million metric tons, and petroleum produces 18.18 million metric tons. Totaling these values shows that the burning of fossil fuel in the US releases just over 2 billion metric tons of carbon dioxide into the atmosphere each year. If these fossil fuel burning power plants were all to be replaced by nuclear plants, virtually all of these CO2 emissions would be prevented, as the nuclear fission process used to generate electricity in these plants produces no carbon dioxide. I must mention that, although this is true, this is not a zero-carbon solution. Carbon dioxide would still be released during the manufacturing and construction of these plants, along with emissions present in the mining, conversion, and enrichment of nuclear fuel. But overall, these emissions would be arguably marginal to the reduction in fossil fuel emissions mentioned previously. So, how much would it cost? The World Nuclear Association estimates that it would cost roughly $4,500 per kilowatt of installed nuclear power in the US today. Again, using the Energy Information Administration's website, I found the installed capacity of natural gas, coal, and petroleum power plants as of 2019. We see that natural gas has 477 million kilowatts of installed capacity, coal has 229 million kilowatts, and petroleum has about 37 million kilowatts. Summing these values and multiplying by $4,500 per kilowatt that it would take to replace these plants provides a total capital cost of $3.344 trillion. Some of this cost will be offset by the fact that, on average, nuclear power plants cost less to operate, maintain, and fuel. The EIA also provides the total operations, maintenance, and fuel costs for multiple electricity generation technologies in the top table shown here. From this, I found that in 2018, it cost 23.86 mils per kilowatt hour, or 2.386 cents per kilowatt hour, to run a nuclear plant, and it costs 3.586 cents per kilowatt hour to run conventional fossil steam plants. Thus, we note a savings of 1.2 cents per kilowatt hour by switching from fossil fuels to nuclear. Multiplying this value by the total kilowatt-hour production from fossil fuels in the US in 2019 presents a savings of $34.2 billion. And subtracting these savings from the 3.3 capital costs found before shows a net cost of $3.309 trillion. In I found that by switching all fossil fuel power plants in the United States to nuclear power plants, we could eliminate over 2 billion metric tons of carbon dioxide emissions annually. In order to achieve this, we would have to incur just over $3.3 trillion in net costs. With such a high cost, it is obvious to say that this transition would take many years, realistically, let alone the fact that you couldn't simply shut off all existing fossil steam plants today and begin the transition. The power grid has to stay online, so plants must shut down gradually to keep up with electricity demand. The real question here, though, is whether or not the reduction of carbon dioxide emissions outweighs the cost to our government. The answer to that question could very well depend on who you ask. But as we all know, climate change is an ever-increasing issue, and we must take the proper steps soon to make a difference. I will say, completely transitioning from fossil fuels to nuclear power is a very ambitious strategy, and indeed costs quite a lot. This is understandably not the best course of action for our society, but this does prove that some percentage of fossil fuels could very well be transitioned and could be worth the costs. To some, though, money is not the only cause for concern, which leads me to other issues. Many people are still afraid of nuclear power, mainly because the first thing that they think of are accidents such as Chernobyl, 3 Mile Island, and Fukushima. This fear is very hard to account for when proposing the transition from fossil fuels to nuclear power. I do believe that much of this fear is based in ignorance or stigma rather than facts. Again, citing the World Nuclear Association, I found that since 1955 in the US, only 7 deaths can be attributed to nuclear power. And of these deaths, not one happened since 1986. I also believe that none of those were due to any meltdowns. They're just other accidents within the nuclear facilities. Another concern that many people have is that of nuclear waste, which is to me a more valid argument. The main question asked is, how can we possibly store all of the waste or dispose of it properly? Although some nuclear wastes can stay dangerous far longer than other hazardous materials, according to the World Nuclear Association, there are no recorded nuclear waste accidents in the US. These materials can and have been stored safely in above-ground casks, underwater containers, or underground for years now. Also, this site stated that all of the hazardous waste transported in the United States, of all of this, only 5% is radioactive. And of this, only 10% currently comes from nuclear power waste. Even by replacing all fossil fuels to nuclear waste increases to only 2% of all hazardous waste, up from 0.5% today. I believe it is more than reasonable that the United States can process an additional 2% of radioactive waste on top of the 95% of hazardous waste that nobody seems to notice now. In conclusion, I believe that further investing in nuclear power could be a great step in reducing our greenhouse gas emissions as a nation. I will admit that far less drastic strategies than that presented here could be implemented, those which still have a considerable impact on climate change. It is vital that we do not let stigma and ignorance get the best of scientific advancement or our planet. It is our duty to preserve Earth and nuclear and nuclear power could be a great stepping stone to a truly carbon-neutral civilization. No solution is perfect, but some are better than others. At this point, we must do all that we can in order to help protect the environment. And these are my sources. Thank you very much for your time and attention.